Okay, so what is a derivative? I am so glad you asked. Um, Essentially, all a derivative is the slope of a function. So you can think here. Let's even put that down. The derivative is the same thing. All right, Avast. It's enough out of slope for right now. We can think of it like that. Usually, you see it written like f prime of x, or if you're using y's, you'll see something like dy by dx. Which you may remember this guy right here. When you found slope back in algebra 1, you did changing y into, well, this isn't really equal, so it's not put equal. But you remember finding changing y over changing x, that's how you find the slope of a line. That's how you find the slope of a function, except you use a d here, and that stands for differential. And all that means is you're not picking any change in y. Like when you find the slope of a line, any 2 points you pick will find the slope of that line. With the derivative of other functions, it's not the same thing. The slope's constantly changing. Like if we look at, I don't know, let's do x cubed. X cubed looks something like this guy. Okay. And let's say we want to find the slope here, and we'll say this point is 1. And the y value is also 1, because 1 cubed is 1. Alright, so let's say we want to find the slope there. Now, what we're going to do essentially here, now you can think about this in like numerical terms here. We can pick any point. Let's say we pick a point, I'll pick a point up here somewhere, right there. We can pick a point somewhat close to this thing. We'll say that's 2. Alright, and 2 cubed is 8. Okay, now I know the scale on here is very off, but forgive me for that for a second. Now we can find the slope between these 2 points, okay, and that would be y1 minus, what am I doing, y2, which is 8 minus 1, over x2 minus x1, and we get 7. Okay, so that's the slope of the line connecting these 2 points, which would look something like this. Let's try our best here. There we go. Beautiful. Alright, now that is called a secant line. So secant. And you've seen the trig function secant, same as x spelling. But we don't want the slope of this secant line. Okay? We don't want the slope between 2 points here. We want the slope only at 1. So picking 2 is probably not a good plan. So maybe we could pick a point closer than 2. Like we could pick, I don't know, 1.5, which would be right there. We could pick 1.1, which would be right there. We could pick 1.0001 and find the slope between those 2 points. Problem with that is it's awfully repetitive, and it's not really, it's not easy. There's just no pattern really. If we want to find the slope at a different point, we got to do the whole mess again. So really we're going to use what we started using in calculus in the first place, which was derivatives. Yo, chill. Alright, I see how it is. Great, let's put him back where he came from, something like that. Okay, we're going to use limits here to find derivatives. So let's get rid of maybe this stuff here. There we go, we can get rid of this. Okay, that'll do. So, here's what I want you to think about. We want the slope at 1. So that's essentially saying what is, now I know I use y here, but let's call it f of x for right now. F of x, which is y. We want f prime at 1. And that's the same thing as saying, what's the slope of f of x at x equals 1? That's all that means. That's all that little prime means. What's the slope there? So, it should be approximately around 7, but you can see here, if I move this point here closer, this line is going to kind of slope down a little bit. It's going to move down a little bit. So the slope isn't going to be 7, it's going to be less than 7. And essentially what we're looking for, now, if you can imagine this. What's up, Sabrina? You're going to be in a video again. You are so lucky. What's going on? Why do you have a big Mountain Dew? Alright. Party. Alright. Now, you can imagine if we found the slope between 2 infinitely close points right here at 1, which we're looking at. The slope would look something like that. Okay, and that's the line that goes through there. That's called a tangent line. And that's really what we want. We want the slope of the tangent line. What's up? Yeah. Alright, and all we're going to do here is we are going to take, let's say, we know one of our x's is 1. The other x, I'm going to pick up here, I'm just going to call that x. And we want the slope between the y values which is y2 minus y1 over x2 minus x1. But instead of using y here, we're going to use f of x. So it's really, this point we're calling x. So it's really f of x minus f of 1 over x minus 1. Because those are 2 points we're using, 1 and x. And what we want now, we don't want the slope between any 2 points. We want x to get infinitely close to 1. And that right there is the derivative at 1. Now we need to simplify this. This whole shebang here is a number. We just got to figure out what it is. So, you what? No, I didn't grade any tests.
No, I have to finish it.
Oh, you have to finish your test.
I wouldn't come at 7 o'clock in
I
the morning.
thought you were excited to see me. What do you have, 10 minutes, 15 minutes?
I don't know.
What period is this? First period? This is not third. That's your final again.
I don't know.
Oh, come on. You started?
Yeah.
You sure about that?
Yeah. Thanks for all. Okay.
Who's this? There you are. There you go. Alright. So, all we're going to do is plug in what f equals here and simplify it down, and that's the derivative. That's really all we're doing here. So, we've still got the limit. Let's get back to the pencil. We've still got, I'm just taking this and moving it up to here. We've got the limit as x goes to 1. F of x is x cubed, so that's all that is. Minus f of 1, where 1 cubed is just 1, over x minus 1. Oh, x is going to 1, sorry. And we just need a number. When we get this number, that's f prime of 1. That's the slope at 1. That's all that means. So the limit is still there, because I cannot simplify yet. Can't plug in, because when you plug in, and this is typical of derivatives, you get 0 over 0. Oh no. Simplify it out. Cubes up here, this is really x cubed minus 1 cubed, which we can factor as a difference of 2 cubes, which if you remember from pre-calc or algebra 2, or whenever you learn this, I'm not really sure. You get x2 plus 1 times x plus 1. All of that's over x minus 1, and these x minus 1s are going to cancel. Now I can plug 1 into what's left. So really what I have left is limit x goes to 1 of x squared plus x plus 1. And that is 3. So all this says is the slope of x cubed at 1 is 3. Now why is that important? Well, essentially we're finding the rate of change, and that's important for all kinds of things. And you're going to see those in calc class, and we'll put up some videos here, and we'll go through why finding derivatives is important. I'm running out of power again. That's the derivative at a point. We can also find the derivative as a function, but really what you should remember here, let's put this in, I don't know, blue. Okay, this is f prime at a point, so f prime a is some number here. Before what we did up here was 1, is the limit as x goes to a. So you're bringing x super close to a point of f of x, which is the first y value, minus f of a, which is the second y value. All of that is over x minus a. And this is our first definition of derivative right there. And you want to remember that. Definition of derivative at a point. So part of my terrible handwriting, and that's this guy. Okay, so anytime you want to prove something is differentiable, which means you can find its derivative, or prove that it's not differentiable, which means you cannot find its derivative, you're usually going to go with finding the derivative at a point and showing the limit doesn't exist or the limit does exist. And that's a key thing here too. If you do all this work here and you find that your limit, no matter what you do to it, you do all your work and get down, that the limit still doesn't exist, well then the derivative doesn't exist. Okay, and that's why you did all that work with limits, because now we can start talking about derivatives. It's really just doing limits that you've already seen before.